Hi everyone. Have you ever struggled to understand the method of multipliers which is used to solve a linear PDE? Now, we will try to break down it in a very simple and exam focused way as to how to solve a PDE with method of multipliers. First, we shall take a problem. The problem goes in this way. Solve mz minus ny whole of p plus nx minus lz whole of q equal to ly minus mx. First of all, we have to write the given equation and check that whether it is in the form of pp plus qq is equal to r or not. Yes, our given equation is clearly in the above said form. Afterwards, what is the basic step we have to use? The very basic step is we have to form the auxiliary equations. So what is the formula for auxiliary equations? It goes in this way: dx by capital P equal to dy by capital Q equal to dz by capital R. So what are the quantities that are there in place of P? It is mz minus ny, in place of Q nx minus lz, in place of R ly minus mx. Previously, in method of grouping, what did we do? We just have considered either the first fraction to second fraction or the first to third or second to third, and see that any common things are lying in the denominator, and we are cancelling the common things and we are using the variable separable method to solve these equations. But here it is not the case. We cannot use method of grouping here. So we have to use some multipliers. So multipliers in the sense, how do they look like? There may be some constants, that means in the sense numbers 1 comma 1 comma 0 or 1 comma 0 comma 1, or even negative numbers also minus 1 comma minus 1 comma minus 1, or you can take some functions of x, y, z. Either you can take x comma y comma z or x square y square z square. These are the common things you have to consider for the case of multipliers. Here, what are the multipliers I have chosen right now to solve this particular problem? I have chosen x, y and z. So, you have to multiply the numerator and the denominator with the respective x comma y comma z, that is x dx plus y dy plus z dz with the numerator part and also with the denominator part, x into mz minus ny plus y into nx minus lz plus z into ly minus mx is equal to 0. Here we observe that the denominator part gets cancelled and we are only left with x dx plus y dy plus z dz is equal to 0. Now we are left with, see the counterparts, x is associated with only dx, y with only dy and z with only dz. So right now we can integrate the terms. Integral x dx plus integral y dy plus integral z dz equal to c. Here we can integrate. So what are we getting after integration? Here what is the formula we have to use? Integral x power n dx is equal to x power n plus 1 by n plus 1. So what are we getting? X square by 2 plus y square by 2 plus z square by 2 is equal to c1. If you bring this denominator, the 2 here to the RHS part, it will become c1. And again we have to use another set of multipliers. So what are they? The another set of multipliers. See here. The another set of multipliers are, we have to choose L comma M comma N. And we have to multiply in the same way what we have done earlier, the numerator and the denominator, L dx plus M dy plus N dz. And if we do the same thing for the denominator, it gets 0 and we are left with here only the numerator one, that is L dx plus M dy plus N dz is equal to 0. So after obtaining this part, what we have to do? We have to go with the regular integration part. L into integral dx plus M into integral dy plus N into integral dz is equal to c2. So after integration, what do we get here? What is the formula for integral dx? It is nothing but x. Integral dy is y. Integral dz is z. So coming to the complete solution, what is the structure or what is the way to write the complete solution? It is nothing but phi of c1 comma c2 is equal to 0. So what is the c1 here? Phi of, it is x square plus y square plus z square, and what is c2 here? Lx plus my plus nz is equal to 0. Now we will go with another problem. So the second problem, what is the second problem here? Solve x square into y minus zp plus y square into z minus xq is equal to z square into x minus y. See, for every model, in every video or slide, I am taking two different problems so that students can understand easily. So what is the first basic step to solve any sort of PDE, either by using the method of grouping or by using method of multipliers? We have to first write what is the step 1. We have to write it as dx by p is equal to dy by q is equal to dz by r. So what is in p's place here? X square into y minus z. What is in q's place? Y square into z minus x. What is in r's place? Z square into x minus y. So previously I have used one set of multipliers in the problem, and these multipliers change according to the problem. See here, I have used 1 by x, 1 by y and 1 by z. Why did I use 1 by x, 1 by y, 1 by z? In denominator part I have x square. So I can easily eliminate them, and if I add all the terms, what do I get? I get 0. That's why here I have used the multipliers 1 by x, 1 by y and 1 by z. So the denominator part gets entirely 0, and we are left with only the numerator part, that is 1 by x plus 1 by x dx plus 1 by y dy plus 1 by z dz is equal to 0. So what is the formula for integral 1 by x dx? It is nothing but log x. What is the formula for integral y dy? It is log y. What is the formula for integral 1 by z dz? It is log z. Here, see, I have taken the constant as also in logarithmic form, so that both sides we will have logarithmic expressions. That's why I have taken here log c1. So what is the formula for log a plus log b plus log c? It is log abc, that is log xy z. So what is the final solution? We have xyz equal to c1. Now using another set of multipliers, here what did I use? My other set of multipliers 1 by x square, 1 by y square and 1 by z square. See, previously I have used 1 by x, 1 by y, 1 by z, and I have just raised the power x to 2, y to 2 and z to 2, and I have cancelled here the terms so that I could get 0, and totally what I am left with? I am left with dx by x square plus dy by y square plus dz by z square equal to 0. When I am left with only these parts, I shall directly go to what? The integration part, integral dx by x square. So what is the formula for integral dx by x square? See, 1 by x square, it can be also be written as integral of x power minus 2 dx. What is the formula of integral x power n dx? It is nothing but n into x power n plus 1 by x power n plus 1 by n plus 1. So x power minus 2 plus 1 by minus 2 plus 1. So what are we left with finally? Minus 1 by x. For integral dy by y square also minus 1 by y. Integral dy by z square also minus 1 by z. So taking the minus common from all these parts, what am I left with? 1 by x plus 1 by y plus 1 by z is equal to c2. So what am I left with finally? So I have found out two independent solutions, C1 and C2. Now I can write the general solution as or complete solution as 1 by is phi of x comma y comma z comma 1 by x plus 1 by y plus 1 by z is equal to 0. Now I will summarize all the steps which I have chosen. What is this method about? This method is about solving a linear PDE by using the method of multipliers. How we must choose the multipliers, or in what case we should use the multipliers? First of all, we should go with the method of grouping. If grouping is not at all possible, then we should switch quickly to method of multipliers. In method of multipliers, what we should choose? We should choose some multipliers called L, M, N. How do they look like? They may be constants, or sometimes they may be functions of x comma y comma z. In these two problems, what we have chosen? Sometimes we have taken x by z, sometimes we have taken 1 by x square, 1 by y square, 1 by z square. Sometimes we have chosen 1 by x, 1 by y, 1 by z. It goes on. So it depends on our discretion. In the sense, we have to think how to nullify or how to make the denominator 0. In that sense, you should think, and it is a simple common sense based thing. If my video is really helpful to you, give it a like and share. Students, also comment below if you want me to cover the next unit or on a specific topic. Thank you, students.